Have you ever wondered what happens under the hood when you run a program on Linux? Today we're diving into how the Linux kernel executes programs. Executable files are the heart of any operating system. Understanding their execution flow is key to mastering Linux internals. Simply put, an executable file is a set of instructions ready for the CPU. On Linux, the standard format is known as ELF, or Executable and Linkable Format. The Linux kernel is the central nervous system. It's responsible for managing resources and ensuring that when you launch an application, it runs efficiently and securely. The entire process of launching an executable starts with a crucial step, a system call from user space to the kernel. When a user types a command, a running program in user space initiates an execve system call, requesting the kernel to load and execute the specified file. This system call acts as a bridge. The kernel intercepts this request, temporarily taking control from the user process to handle the task. Once the kernel has control, the complex process of loading the executable into memory begins. The kernel first determines the executable's format. If it's an ELF file, a specialized ELF loader is invoked to interpret its structure. The executable's code and data sections are mapped into the new process's virtual memory space. This is done efficiently, without immediately loading all data. The kernel prepares the environment for the process by initializing the stack, heap, and passing command line arguments and environment variables. For executables that rely on shared libraries, an additional step called dynamic linking is required before execution can truly begin. The dynamic linker, often /lib/ld-linux.so, is executed first. Its job is to find and load all necessary shared libraries. It resolves any function calls and variable references within the executable that point to external shared libraries, ensuring everything is correctly linked. With the executable loaded and linked, the kernel prepares to hand over execution control to the program itself. The kernel sets the CPU's registers to the initial state required by the new process, preparing the machine for execution. Finally, the instruction pointer is set to the executable's designated entry point, typically the _start function, to begin the program's execution flow. The moment the kernel jumps to the entry point, your program officially starts running. The executable's instructions take over, and your program begins its life, performing the tasks it was designed for. The kernel returns control back to user space, now running the newly created and loaded process. From a simple system call to dynamic loading and register setup, the Linux kernel performs a monumental task to efficiently run every program on your system.